Hello everyone, my name is Yogesh from TY Electrical Department. So our topic name is effect of system type and integrators on state error for different inputs, guided by Dr. G. Vijaya Kumar sir, presented by four members, Wag Nilesh, Wag Sar, Vani Rushikesh, and Yuvraj. So let's start our presentation. This is all the contents about our topic. Introduction, overview, methodology, simulation, block diagram, simulation result, advantages, disadvantages, application, conclusion, and references. So let's start the introduction. Control systems are widely used in various engineering applications such as electrical system, mechanical system, industrial automations, robotics, and communication system. The main purpose of a control system is to make the output of the system follow to desired inputs accurately as possible. One of the most important performance parameters used to evaluate a control system is the steady state error. Is defined as the difference between the reference input and the actual output of the systems after the transient response has completely settled. The performance of a control system depends greatly on its system type, which is determined by the number of integrators presented in the forward path transfer functions and integrator in the system is represented by one by S. The presence of integrators improves the ability of systems to track the input signals and reduces the steady state error. Based on the number of integrators, control systems are generally classified as Type 0 system, Type 1 system, Type 2 system. Type 0 system is no integrator. Type 1 system is one integrator. Type 2 system is two integrator. As the number of integrators increases, the system becomes more accurate in different in following the desired input signal. Different standards test input such as the test, tram, and parabolic signals are commonly used to analyze the steady state performance of a system. First, step input. Step input is R of t is equals to 1. Ramp input R of t is equals to t, and parabolic input R of t is equals to t square. This is the equations about the input. Each of these inputs helps in understanding how well the system respond to different types of signals. The steady state error for these inputs changes uh, according to the system type. So next slide is overview. System types depends of the integrator 1 by S in the system. Type 0 is no integrator. Type 1 is one integrator. Type 2 is two integrator. Standard inputs are step input is constant, ramp input is linear, and parabolic input is quadratic. So each of the inputs helps in understanding how well the system responds to different types of the signal. The steady state error for these inputs changes according to this system type. So in this project, MATLAB simulation is used to develop a simulation model for analyzing type 0, type 1, and type 2 systems with different input signals. The outputs are compared to the study the effect system and system type and the number of integrators on steady state error. This analysis helps in understanding the practical importance of integrators in improving system performance and accuracy. So next slide presented by Wagnish.
Myself, Nilesh Wag, I will explain the methodology of this topic. In this project, we studied how different types of systems behave by creating type 0, type 1 and type 2 system based on the number of integrators. These systems were designed and testing using MATLAB or Simulink software. After designing the system, we apply standard input such as step input, ramp input, parabolic input to check the performance. The output of each system was observed by using scope to understand how it responds over time. Then the steady state error was found by comparing the input and output values after the system becomes stable. Finally, All the results were compared to see how increasing the number of integrators reduce error and improve system performance. This is all about methodology. I will show you the actual simulation. So let's start the simulation. First, we need three inputs because we combine all nine simulation in one simulation. First, uh, we take a step input. So double tap to screen and type step and click on step block. Also double tap and type ramp input. So click on ramp input. So drag the step input and ramp input left side. After that, in this MATLAB, there is no parabolic input. So we take two input to make a parabolic input. So we take clock block, type here to clock and click on it, enter. Drag this to left side. After that, we need mathematical operation blocks. First, we need double click on the screen and type product. We use product because the in this MATLAB there is no parabolic input uh, block, so we need a clock and product block to make a parabolic block. After that, we need three sum blocks. Type here sum, copy this block and paste two times. Three blocks is here. After that, we need one mux. Type mux. Uh, After that, one multi-port switch. We need multi-port switch. Multi-port switch. Uh, After, we need three gain blocks. Type here gain. Copy this. Paste two times. We also need three integrators. Copy and paste. And for uh, see the output, we need a scope. Type scope and also here. Uh, here, here is all blocks are available. We connect the all this connection. First, there is one step input, ramp input, and here is a parabolic input. Uh, we connect the input of clock to product input here. Mm, we need one constant block. Here is our three inputs. inputs, we connect it into multi-port switch. We connect constant into uh, first to multi-port switch. After that, we connect step input to here. After that, we connect ramp input. Also, we connect parabolic input. This is our input side. After that, we connect multi-port switch output to a sum. We have three sum blocks, and we connect this input into three sum blocks input. First, connect this. After this, and then this. We change the sign of sum. So we double tap on sum block. Here is a plus plus. We only change one minus. Click on apply, then OK. Here is also same process. Apply, OK. Here is also apply, OK. After that, we connect gain to first sum block. Second gain to second sum block. After the output of sum into the gain. We connect integrator in second gain. We connect two integrators for type 2, and all the output of this type 0, type 1 and type 2 connected into the our scope. No, sorry. After we connected scope, we this connected into the mux. There is only two inputs. Click on mux, and type number of input is our 3. So apply, cancel. Move this in here. Connect all outputs of our type 0, type 1 and type 2 to mux input. Connect this, also. After that, connect the output of mux into the input of scope. This is all about our simulation. Uh, our top time is 10. It is correct. So we want to see the output waveform for type 0, type 1 and type 2 for each input. First, we check the type 0. So we want to type here 1. So is it already typed? So we click on run. So this is the output waveform of type 0. We want to check type 2. Apply. Same process is also here. Run and click on scope, and we see the output of type 0. I will explain you in the PPT. I will show the all waveform of type 0, type 1 and type 2. I will I will see the type 2 waveform. So click here, type the 3 and apply, and next is run. After that, click on scope, and this is a output waveform of type 0. So this is our actual simulation and all the waveform. I will tell about all output waveform. I was told you methodology and also simulation. Next is I will explain about all this input, all these input results. In our simulation we got three results based on inputs. First, step input, ramp input, parabolic input. Each graph shows comparison of type 0, type 1 and type 2 system. First is step input result. In this graph, uh, we got three waveforms. First waveform, the orange color is type 0, blue color is type 1 and yellow color is type 2. For type 0, output reaches near input but some error remains. For type 1, output reaches input with almost zero errors. For type 2, output perfectly match the input. Or the final conclusion of this step input. For step input, type 1 and type 2 are better than the type 0. The next waveform is ramp input. Here is also same color. Type 0 cannot flow input, so large error happens. Type 1 follow input but small error is here. Type 2 almost perfect tracking, very less error. Our final conclusion for type 2 gives best performance for ramp input. The next waveform is parabolic input waveform. For type 0, very poor response, therefore very large error is created. For type 1, still large errors. Here is also large errors. For type 2, for type 2, here is only small errors. Our final conclusion is only type 2 perform well for parabolic input. So our final observation is for type 0 worst performance, for type 1 medium performance, type 2 best performance. As system type increases, graph get closer to input line. From the simulation graph, it is clear that higher system type reduce error and improves tracking, which is shown by green curve being closest to input. This is all about simulation and waveform. The next advantages and disadvantages is explained by Sarthwak.
Myself, Vaksar. So I will explain the advantages and disadvantages of this topic. First is the advantages. First point is reduces steady state error. The system output becomes closer to desired the values. Second is better tracking of input signals. Follows input changes more accurately as possible as. Third is helps in designing the efficient control systems. The system makes more comfortable or performance should be high, reliable, useful for analysis and comparison of system. Easy to compare with different types of systems. And fifth is improves system accuracy. Overall precision of the system is increases. So the disadvantages are: first, more complex system design requires additional components and calculations. Means it is one type of disadvantage of this system. Second point is of disadvantage are higher computational efforts in simulation. Simulation and analysis becomes time consuming. In simple language, we tell that it requires more time to simulate. Third is increasing indicator may reduce system stability. System stability means it system may be becomes unstable. It is not in unstable, so it is one type of main disadvantage. Fourth point is may introduce oscillation if not properly controlled. If not properly controlled means the poor control can be cause unwanted fluctuation. Fluctuation is we wanted a fluctuation, but in this disadvantage fluctuation is unwanted. Hello everyone, I am one. Today I am going to explain application of this system. In this presenting the concept of steady state error. It is steady state error. It is defined the difference between desired output and actual output. In application, we are going to see that speed control of DC motors. In this application, it controls the speed of DC motors. Also, second point is automatic voltage regulation. It regulates automatic voltage of motors, and the system is becomes very large, and that after the system is completely responded. This parameter is very useful to perform performance of the system in long-term operations. In long-term operation, in control system, the steady state error mainly depends on the type of system which is determined by the number of integers present in the system. Also, the second application is robotics and automation system. It is used in robotics and automation system for integration purpose. Also, in server motor control system, it is used. Also, in aerospace and navigation system, it is used. The because the system with integrator, it is called a type 0 system. A system with one integrator is called type A system, and the system with two integral system is called type 2 system. As the number of integral increases, the steady state error decreases, and accuracy of the system decreases. The presence of integral reduces the steady state error because of this, and also it tracks the step inputs zero errors, including making the system. Also, it is more efficient than the type 0 system. Uh, Also, it also eliminate the both step by ramp inputs and provide the highest level of accuracy among the all the system. This concept is widely used in application. For example, the speed control that I have explained of DC motor automation, robotics automation system, servo motor control system, aerospace navigation system, and industrial process. It is essential for presence movement and pro positioning. Similarly, for server motor control system that I have explained, server motor control system, because in server motor control system is used in principle to achieve exact position of speed control. In aerospace, the 4 point is in aerospace. In aerospace navigation system, highly accuracy is very important to control the aerospace system. It is critical for functioning and industrial process control. This system helps in regulating parameters like temperature, pressure, and flow of to ensure the efficient and safety operation. Now, next slide. In conclusion, the study shows that the steady state error depends on the system type and number of integral. This conclusion says that the steady state error system depends on the type of system, whether the system is open loop or closed loop. The type 0 system have higher error. The type 1 system reduce error, means there are three systems: type 0, type 1, type 2. Type 0 system have higher error, type 1 system reduce error, and type 2 system provide a basic accuracy, reduces error, and enhance tracking capability. However, adding too many integrals can make the system unstable. Because of that, so proper design and balance are necessary. Therefore, engineers must be carefully choose the system type to achieve the performance and stability of the system. Thank you.